Hello everyone, my name is Spandana, working as an assistant professor in the Department of BWork, Software and Application Development. In this video, let us look into the topic named Android Runtime. Android Runtime is the runtime environment that Android apps runs on. A mobile operating system developed by Google primarily for touchscreen devices such as cell phones and tablets. Before getting into the overview of the Android runtime, let us look into the history of the Android. In 2003, Andy Rubin, along with his co-founders, founded the Android. It was initially intended for digital cameras, but the focus shifted to smartphones due to the limited market for camera-only devices. In 2005, the Android team joined Google to develop a platform for mobile devices. In 2007, Google officially announced the development of the Android operating system. This announcement coincided with the formation of the Open Handset Alliance, a group of companies working together to develop open standards for mobile devices. In 2008, the first Android smartphone, HTC Dream, also known as T-Mobile G1, was launched, marking the beginning of Android's journey in the consumer market. There are two execution engines. First one, Delvic Virtual Machine, and the second one is Android Runtime. DVM, Delvic Virtual Machine, served as Android's original virtual machine until Android 5.0. In Android 5.0, ART, Android Runtime completely replaced Dalvik Virtual Machine. Let us look into the working of Dalvik Virtual Machine. DVM, Dalvik Virtual Machine utilizes a register-based architecture and just-in-time compilation to efficiently manage memory, battery life, and performance in mobile devices. JIT, just-in-time works compiling frequently used code to native while keeping less used code interpreted. In Java C, compiler processes all the Java source files which are present in the project and produces Java bytecode in the form of .c files. .c files are platform independent. The DX tool takes all the compiled .c files, compiled .class files, and converts the Java bytecode to Dalvik bytecode. Combining multiple .class files into single .dex file while optimizing the code for mobile execution and reducing redundancy. During the APK packaging stage, AAPT, Android Asset Packaging Tool bundles the .dex file with processed resources, includes all the required libraries and assets. That includes strings, XML files, and also the drawable folders, all the files in the drawable folders, while compressing and optimizing the package size. The final output is single APK file that contains all application components, is optimized for mobile execution. One more virtual machine is Android Runtime. ART require Dalvik bytecode. Both for the Dalvik virtual machine and also the Android Runtime, Dalvik bytecode is required. So the procedure for the formation of the APK file remains same for both Android Runtime and also the Dalvik virtual machine. Let us look into the working of the Android Runtime. Android Runtime employs ahead of time compilation, which converts .dex Dalvik executable bytecode into native machine code before execution. This compiled code is stored in .oat, optimized Android runtime files, reducing the need for just-in-time JIT interpretation at the runtime and improving the performance. In the current Android version, starting from Android 7.0, a hybrid approach called profile-guided compilation, combining both JIT and AOT compilation, It initially uses JIT compilation while collecting the profile data about the application's execution patterns, then uses this data to perform AOT, ahead of time compilation of frequently used paths during the idle periods, providing the benefits of both approaches. Thank you.